first thing to say, like, I'm very happy to be here. I'm very happy to be taking over the second part straight from Paulo. I am Fabiano Fidencio. I work for Intel. And together here with me, I have Mikko Ilinen, who has been my right arm inside Intel. Mainly now, as you can see, like my right arm, my left eye. You know, like, and we will be talking about like what is on the application side, what we are doing, how we are consuming, what Paulo is doing, and well, a little bit of problems that we faced there. Anyways, just get back a little bit. So the title of the presentation is like living in stilt houses. Stilt houses, for those who are not familiar, we call these palafitas. Those are houses built, you know, across the river banks, and they have to support like high flow, the high stream flow, or the low stream flow. So they have to be prepared for any kind of environment changes there. So those are quite common in Amazon in Brazil. And I just would like to give a shout out to the photographer of this, who is one of the best nature photographers in Brazil, who just gave us the license to just use those pictures here. So that's the analogy we're going to do, because the applications have to just like get around with all the changes that are happening like below them. So this is going to be like more a conversation than a presentation. Do not expect anything too technical. Like, we are just gonna talk a little bit about what like Paulo is doing and other kernel developers are doing, how it's gonna impact the apps. Just use the space button. Yeah, and then we don't have a PDF something here, so yeah, happens. Oh, it does work. Yeah, so we're gonna go through the known challenges, and next slide, just gonna talk a little bit about the known challenges. We're gonna go a little bit about the workarounds that the distros usually take doing this kind of development, and also the drawbacks that this is gonna just bring. So yeah, let's. And one like quite important thing, that is like, what are the expectations that we have, maybe naive expectations that we have from hardware vendors. How we can get some help from the distros, and the naive expectations that we have from the hardware vendors. So Paulo mentioned a lot of things here, and one of those that you you can clearly see, like, there is a high flow of changes coming. In the early stages of development, those changes are usually incompatible, right? Like, usually people are doing this development, they are not getting things right on the first time. So applications, usually like hardware vendors, want to test this kernel code together with the applications they are developing, and that end up like putting us in a situation where we have to deal with incompatible changes and have to deal with these in the application layer, which is just like a mess. Then, because of that, we end up like having to support different kernel stacks. So let's say I have a hardware that I want to enable a feature today. I will start developing on top of 611, maybe 612 when it's released. All the patches will go upstream. There is a review coming, and then like by the moment I can resubmit something, it's like 615, maybe 616. And then like we will get the parts that we have done right and pretty much rewrite the other parts. And for the applications that have to support the other part, you end up like just with those broken changes that you have to just like have your workarounds there. And as Paulo mentioned, like when you bump a version of the kernel, there is a lot of features that just come for free, a lot of bug fixes that will come for free, and a lot of bugs that will also come for free, right? This is the nature of what we do. And maybe it's okay to have like a big team to deal with that. Usually people don't, right? So, and the last part is, when you are dealing with the first versions of the stack, you are actually relying on something that will never see the light of upstream, which is not good to anyone. And then like we have the known challenges that we are quite familiar. Hardware development is slow compared to software. Software development for this part of confidential computing is quite complex, as Paulo could mention here. Then software enablement can and will take years. Like SGX from Intel is one example. But even if you take a look at the timeline that Paulo shared about the S&P and TDX, this is taking like 7 years. Right? That's like a lot of time. And of course, the amount of moving pieces is huge. Paulo mentioned about kernel, QEMU, libvirt. There is also like OVMF, the firmware that is involved. And then when you get to Kata containers, there are other components that are involved that are related to attestation. So Kata containers itself is moving, confidential containers itself is moving. So there is like a lot of moving pieces that we have to just put together. So what the distros usually do is something that Paulo mentioned already, is like, hey, we are going to just do the development on top of one specific version, put the source code somewhere, maybe sometimes a link, not even a GitHub, where someone can just go there, download that, build it. Maybe it will work, maybe not. Hopefully it will. Hopefully they will get all the parts correct that will make it work. But that's painful. That's like really, really painful. And there is also something else that is complicated, that is usually like when you start shipping this to customers, right? Because you have your hardware out there, you want the customers to start trying this. So you start just shipping those links to customers and say like, hey, have fun with this. And then your customers may end up building something on top of something that will never, ever work. Or will work on that specific tree only. That causes a lot of problems to handle integration, problems to handle maintenance, which is fine for, let's say, Amazon, Google, Meta, Alibaba. They have huge teams. Middle-sized companies, not so much. So that becomes a problem. And we mentioned about maintenance, right? So maintenance nightmare. We are just going to start talking about the drawbacks now. Next slide, please. Yeah. Drawbacks. Maintenance nightmare is the main drawback that I can see here, because I can just imagine one small company having to go through the whole process that Paulo mentioned about curating patches and testing and everything. But there are also other problems, like building your own stack is not easy. Who here is building their own kernel? Pretty much everyone, right? But this is the wrong audience, right? The customers are not building their own kernel. They don't want to spend time on that. They don't want to have a way to, put this whole thing together. They want to rely on someone that does that for them. And usually they are paying someone to do that for them already. And then when you are building your own kernel, you get into some kind of lack of contractual support, which is like, let me ask you a question here, for instance. We have some folks from Red Hat. Does Red Hat support running your own kernel? Of course not. Mostly not, right? So if you want to do any kind of reasonable experiment, like know that everything is going to be supported, ideally we should have come something from the distros, right? From the enterprise ones, either coming from SUSE, from Canonical, from Red Hat. So this is one of the points. And then there is those two go together, a lack of communication, usually coming from the hardware vendors, and a problem with the expectation coming from those consuming the content from the hardware vendors, right? The hardware vendor is not going to put something upstream and tell you, well, it's going to change a lot. I'm not sure if you should use, right? The hardware vendors are just there saying my hardware is amazing, use it, get it to production as soon as possible. And then the customers are just like, oh, whoa, we have some a reasonable assurance of maintenance there, which is not the case, which is really not the case. So here we come to the interesting part. We need the beavers, right? We need to get some help from the distros. And distros can help us a lot on this. The first thing is, and I hope, like, do we have folks from hardware vendor here? Do we have folks from AMD? Do we have folks from ARM, RISC-V, maybe? Well, we have at least one, okay. I know that, like, the most part of the folks working here, they work for distros as well, right? So I may be just praying to the choir here, but distros maintainers know way better what are the distro specifics. They know way better what are the timelines they are comfortable to get the patches in. They know way better what is acceptable for them to maintain something. You know, maybe for 4, 5, 10 years if needed. So, and they know exactly how they are going to do that. What are the criteria for everything? So the distros maintainers are here to help, and they know better than the hardware vendors about what has to be there and how things have to be there. And this usually happens because the distros maintainers, well, I can surely say that in our case, the folks that we are dealing with, we are like working together with folks from Red Hat, folks from Canonical, folks from SUSE. They are kernel maintainers. They are QEMU maintainers. So they are following closely what's happening upstream. And if you are maintaining a project downstream, you should be following what's happening upstream as well. So by the moment we get to agree that distro is going to do like a better work for us than just like a link in the internet, we can see like, I think like it's quite easy to agree that installing something from the distro with your DNF install is way easier than building your own stack. DNF install QEMU KVM, and then it's going to bring the firmware, host kernel. So you have everything that you need there already. And there is another important part that is how this easy installable and implementable path allows us, like on the application side, to just start working on the products that are built atop of the distro. If it's not clear for everyone what I'm talking about, let's think about OpenShift. OpenShift is a product from Red Hat. It's built atop of RHEL. They do a rebuild of RHEL. It's called RHEL CoreOS. And it's not so easy to get a bunch of binaries here and there and just like layer this atop of what OpenShift is using. But thanks to the work done on CentOS String, it's very, very easy for me to just have like an RPM layered atop of what is OpenShift providing. And of course, I should not distribute this to a customer. But this allows me to start testing and integrating that Kata containers or confidential containers works very well with OpenShift and TDX today, and it does, before everything gets upstream. So whenever things will get ready, those things will get ready together. And that helps us a lot. And for the distros, it's fine. It's very, very fine if something comes as a third-party repo. We are not asking the distros to just like, hey, we have this patch here. It may not be stable. Support this for 10 years. Right? This is insane. We are not asking for that. But just try to give us an easy way to test it, integrate it with your distro. We really want to make sure that the QEMU that we are running is going to be compatible with everything else that you have in your distro and things like that. Let me just pass the mic to Miko.
Okay, yeah, so I'm gonna walk through this one slide. I apologize my voice. It won't take long. So what are the what would be our expectations from the hardware vendors, or best practices rather? This is something that is based on what we have seen. Take of these as lessons learned or tips to avoid any road bumps in the future. one thing related to what Fabian said just previously on this distro integration. Packaging is a pain. Distros and distributions know how to do it better. This is based on some of our experiences when trying to get some of our attestation-related packages integrated into the distributions. We have seen or faced some struggles getting our existing packaging to meet the quality criteria for packaging that the distros may have. They are often much stricter criteria and what we had learned was that, okay, we did something, but hey, that didn't quite meet what the distributions were expecting. So get the integration work started early on, get help from the distributions. One good example where this has been pretty successful, we have had Daniel helping with some of the attestation-specific libraries on getting the reproducible builds support improved. Reproducible builds is a critical, at least for the libraries that we are dealing with here, related to the attestation and quote signing. One other thing that's also critical or important to remember on this packaging side is if you have your software that comes with new releases in the future. So make sure you know what the distribution integration timelines are so that you get to deliver the best and the latest features to your customers also for consumption. And the second thing, which I think is the most important thing or the most important takeaway out of this slide is the collaboration with competition can be very beneficial, and there are lots of examples here that we could highlight. I have two examples covered here. So first is the recent addition in the Linux kernel to get a vendor agnostic confidential computing report API agreed, which is something that is now we are able to get rid of all the vendor specific IOCTLs. We have a common framework that we now know how hardware vendors get their TEE support integrated into the guest kernels. On the Cocoa side, we already have TDX, and most recently, if I remember correctly, also ARM moving to use this interface. I think we have still AMD support missing, so we welcome any contributions to get that part also covered. Community engagement, so get that going sooner than later. Cocoa side, it's a great example where the project got started. So it was taken as one of the main drivers or main goals for the project that it needs to be vendor agnostic completely. We support, I think, like 5 to 10 different hardware TEEs, but it's done in a way that none of these hardware specifics are visible to any of the users of Cocoa, which I think is pretty amazing what we have to offer. So it's all hidden under the hood, and no one would know if you run on TDX or SCV. So that's pretty cool.
Yeah, this is like, we have like 5 minutes, and I think that's one thing we can just take questions, comments. Paulo is here, so we can take questions for the previous session as well. So yeah, your time.
So couple of comments on the previous slide. The first thing here is, I think, at least from the hardware vendor perspective, we are starting to collaborate quite a bit earlier. Paolo is aware of what we're doing in the trusted IO space. But at the same time, one of the things you have to keep in mind is, at least when we try to unify interfaces, the first vendor in gets to make their choice. The second vendor in gets to unify. So, well, we are all trying to get features enabled quickly.
So it depends. Like the first vendor certainly has more flexibility, but sometimes it's not feasible to have a different user space API, which is what I mentioned very quickly. In like SMP code has been ready for a while, but we were stuck on GasMMFD because there was an understanding that GasMMFD was an important part of the enablement of confidential computing. So I did feel bad for AMD that had the code almost ready, but the first vendor has more flexibility, but they should still do it right.
Yes.
I would say, like, regardless of who is the first vendor, like having in mind that we may have a common architecture is something that they should always be prepared for. So you have more freedom, but you also have more responsibility on what you are doing, right? So exactly.
Come here, Dhaval. Come here. We are going to chat a lot. Come here. All right. So
I'm trying to bring my context back in. So, at least with Trusted IO, for example, we are trying to have all of these discussions early, but sometimes it's pretty hard to try to get to a common interface without seeing what's happening elsewhere. Last year, when we started Trusted IO, IBM folks had their own implementation where we did not think we needed Linux support, for example. Now we're finding out, well, maybe they have similar abstractions. These things take time.
This takes time, and this is a valid approach. But if you have the opportunity to talk to someone while you're doing this, do the talk. This is the main point.
generally, what ends up happening is the talk happens upstream, and people don't know someone else is also working on it. So it's good to post patches early and often, and maybe there's an opportunity to just push things into staging instead of having to. And that's a way to enable collaboration before figuring out what the user space APIs are going to be like.
Yeah, there are rules for what goes into staging, but we were discussing about having our own Linux Next tree that includes both Intel, AMD, and hopefully also ARM and IBM technologies. But with a small catch compared to Linux Next, that is, if you have conflicts, Linux Next tries to merge things, we would merge neither. So you have to collaborate if you want the tree to be available to users and to distros in the same way. Yeah. And also include both kernel, QEMU, and libvirt in the same GitLab organization. Like
so it's
firmware 2, yes.
So it's a CentOS SIG.
No, it's an upstream thing that we just talked about and may happen. We don't know when, but it's an idea.
Well, it could be a CentOS SIG. Why not? Because eventually that flows into.
No, this is for upstream. Then if CentOS wants to consume it, that's a different story. But this would be for upstream developers, like both them and the Linux kernel.
I think the more important thing over there is the user space API anyway.
Yeah, yeah. So we need to include QEMU so that you can have something that works at any moment. But of course, the user space API is subject to change, and you would have to have everything in Lobster.
Exactly. Yes. Exactly. So one of the things about the distro aspect of things also is that the hardware vendors probably do not know how to do packaging right. There are a few people who would, like you mentioned, Paolo, Daniel probably. So having shell scripts from distro vendors already helps. From the hardware vendors helps people who know how to do packaging right, and they can convert shell scripts into RPM or whatever else format.
Yeah, that helps, but like, let me just make my point like a little bit more clear here. One thing that we have noticed is like people inside hardware vendors, companies, they are very, very opinionated on their capacity to do packaging better than, let's say, a company that is like 30 years out there doing packaging, right? And they are like, oh, packaging is easy. Well, it's not, right? We have like a lot of companies that their own business is make sure that the packaging is sane so you can use it without any kind of problems. So having a script will help, but like knowing the limitations of your team and getting to the distros or someone from the distro and say like, I need help to package this. How do you think this should be packaged? Is the most important part.
And also on the other side, like I can and will gladly pick up the final stages of a series so that I can integrate it with things that I know that are going on. And especially when you need to do very fast turnaround to fix the last couple of things before merging a series. But at the same time, for the first part of the work, someone like me needs Intel because I don't even have the hardware. Like, how do I do development?
Same
So
goes for
it
me.
has to be a multi-step process with different people working on each step.
Yeah, same goes. So, which is kind of why I said CentOS SIG also makes sense in that upstream world, because just having a SIG at the outset helps with the entire view.
I agree with that, but like that's a second stage. The first stage, like let's have everything upstream, and then
Of
like we
course,
get into
yeah.
the SIG. I would suggest like just one thing. If someone can work for the distros companies for like maybe almost 10 years and then move to hardware company, they can start like forcing that, right? So I'm not saying that someone here has done this, but well.
Exactly 10 years at Red Hat and now at AMD. So,
So I wanted to mention one sort of specific example of something that we ran into in confidential containers, and also put a slightly different spin on things. So one thing that we rely on for attestation for SNP is the extended report. We assume that when you get to the verifier, you're going to have the extended attestation report, and that's how we get like the VCheck or the VLAC, right? So there's a little bit of a history to that feature in QEMU, and the kernel, originally the extended report was set like via an ioctl, and it was set per like host, and you would set it like once per boot, and then you would just get it whenever you did an attestation inside the guest. And then at some point it was decided upstream that actually QEMU should have it be able to be set each time, like for each guest, which is pretty reasonable. And then there was a decision upstream pretty recently, I think, to actually not include this at all in QEMU or the kernel. So now we don't have that at all. And there is a fallback to this. You can get this from the verifier side, although it's not totally optimal. But this is a very concrete example of how we need this thing to be able to do attestation. We write some code that depends on it, and it changes. And we can't really complain about that because we're dealing with upstream stuff. But also, the longer it takes these lower levels of the stack to merge something, the more that higher levels of the stack are going to be doing stuff like this, and that's sort of inevitable. But
yeah, so talking specifically about the attestation report and the extended report, that is actually something that was dropped just because it was not ready, to avoid delaying even more the core support. But another example that I would make that hasn't even been posted upstream yet is the VMPL and SVSM support. So these are things that you will get from a vendor kernel, you will not yet get from upstream, but something like the CentOS SIG could actually include it. And like now I've done my first part of the job, SMP is included. I want to already move ahead and include this VSM support, even if the API is not finalized.
yes, I think one difference between those features is that this was included and then removed or changed, and that's a little bit annoying. But I actually am not that upset about this, because I think that this is kind of, in some ways, the point of confidential containers. Yeah. Like Miko was saying, this is a project that's trying to unify these things. This is the work we're doing. Like, this is what we give users, is that we take the bullet here, in some ways, almost like a distro would, to get all these things to work seamlessly.
Yeah, there is some similarity between what developers like Kata containers do and what the distros do, and that's why collaboration works well. Like, time is over.
One last thing that I would like to just show here, like there is this last slide that I would like to leave you guys with, that is, a software product is not fully developed unless it can be easily and widely used. And usually it comes by being present in enterprise distros, right? This is something that people buying the content to use, they want to have this box to check that if something goes wrong, we have the enterprise on our back to just cover us on that. So when you are doing a product, you made the hardware, your product's not done. You made the software, you put this on your hardware vendor web page, this is not done, right? It's done when people can actually use anywhere in an easy way. And that's it. Thanks for being here.